Okay, I wanted to go through the solutions to this Kirchhoff's law problem. Even though I asked you to show this example, you could have just done it by the simulation. Some of you guys did it that way, or you could have solved it in a little bit more of a complex way, like you did the prior problem in that set. So let's talk about our current. So we have, in this case, we have 5 unique currents that we selected. And I tried to color them, so hopefully they'll come through in the video. I1, I2, I3, I4, and I5. I1 being this current here, I2 in blue, I5 on the outside, I3 and I4 going to the right. This one was a given formula. So understand that when we select the direction of the current and the direction in which we're going to do our calculations in this loop, they are completely arbitrary. So, and we're also assuming that this is looked at in the conventional manner. Typically, current flows in the direction that the electrons flow, but we always look at this in the we usually look at this in the conventional manner, which is opposite. So again, keep in mind that these directions are subject to change and they are arbitrary. Okay. So we need to pick off a couple of equations. So on the right over here, you can see 7 different equations that I picked off. Let's understand where I got these from. N1 stands for the first node, and in each one of those nodes, remember, this is Kirchhoff's current rule, which basically says in a nutshell that the sum of all currents, the net sum, is going to add up to 0. So current in is going to equal to current out. So we're assuming here that current 1 flows into this node, thus the other 2 will be the additive inverse of those 2 since of I1, since the net flow should be 0. And so likewise for node 2, you can see and I2 is an input, I4 is an input, and I5 is extracting, if you will. And I go through that for all 4 of those. Again, keeping in mind that the direction of the currents are arbitrary, so they're subject to change. The second part to this is that we need to know, using Kirchhoff's voltage rule, what the voltage across each one of these entities are, and you got to really pay attention. So keep in mind what these correspond to. These are just voltages, and we're going to look at the voltage in a specific loop. So in L1, I typically start in the bottom left corner. Pick your poison in terms of where you want to start from. And this is my indicator of which direction I'm gonna sum. You can rotate counterclockwise if that's your choice. It's again completely arbitrary. So if I start here, I'm looking for voltage drops. And if I assume that my current is flowing across this resistor, as we go across a resistor in the direction of the current, there's going to be a voltage drop. And so what is that voltage drop? Well, right now, we're going to assume it to be negative I2, which is current times the resistance, which was given. Again, flowing through this part of the loop. And again, we hit another resistor. We assume this time that the current is flowing opposite of the direction that we're doing our calculation in. So we're assuming that the current is flowing in this direction to my right, but our loop calculation is going to the left. So in this case, there's going to be an increase of the voltage. So we're going to go from, let's see, over here, we went from positive to negative. This time we're going to go from negative to positive. So there's an increase of the voltage in this direction. So that's where in loop 1, we get this plus sign here, right? And then continuing through the loop, there's another increase of voltage according to my scenario, and we get that equation. So you're going to do the same thing for the other two loops. So L2, in this case, there's a voltage increase. And again, pick your poison, figure out where you want to start, which you're most comfortable with. I like to start typically here. And as we go across this battery or this power source, there's an increase in voltage. We're going in the direction of the current. So there's going to be a decrease. So it's going to go from positive to negative. We're coming across here. These were given. And so in this case, going with the current across the resistor, there's going to be a decrease as such. So you do the same thing for L3, we'll get that equation. And now it's sort of a puzzle piece. You have to figure out which equation leads you to what. So at this point, I'm going to start off with looking at L3 because that has the one unknown. So if I look at L3, I can easily solve that for I4. You'll notice that when you solve this for I4, the number is negative. Now, you're going to have to keep that in mind. And also, since we're dealing with the system, we don't want to change that numeric value just yet. So use that value when you start substituting into other equations. You'll see, again, I'm looking for an equation such that I either have one unknown or I can substitute. So in this case, since I have what I4 is, I realize that I can go into this equation that comes from the node equation or the sum of the currents. And I just simply plugged in here for I4, solving it. Again, seeing I get a negative sign, not too big of a deal, and so on and so forth. Okay. So everywhere that we see a negative current is an indicator that the selection that I chose over here for my current directions need to change. So fast forward into what we have. See if I get that last part on there. I can see that I4 is going to need to change its direction. I3, I2, I1, and I5. So all of the directions that I selected here, I selected in the opposite direction, the wrong direction, no big deal. We just make that correction over here. Okay. So you can see I changed the direction of each one of those that had a negative sign, and I come up with these values. So, and then the last part was just simply to figure out the power through this battery on the right. Power that's emitted through this is going to be the current times the voltage. So in other words, 300 watts. So go through this exercise. You'll probably see it on the final exam. You'll definitely see it in your lecture if you guys get to that section. Most instructors do that section in Kirchhoff's law. Remember that direction of current is arbitrary and direction of loops is arbitrary as well. All right, hope that helps.